Is the most of our cases involve permutations, or we use the fundamental counting principle. We use factorials. That is still very much alive, but there are instances where the order of the elements matters. That's permutation. Okay. So A and B, or B and A, especially when you're arranging for a picture or something, we consider them two different cases. With combination, order does not matter. So order does not matter. I sometimes have that written next to a question. Order does not matter. That's what that means. AB and BA are considered the same outcome. So some examples. You're just picking 6 numbers on a lottery ticket. If you buy a 649 ticket, the order in which you pick the numbers does not matter. As long as you have the 6 numbers that are the winning numbers, you would win. Okay. Choosing or selecting members for a committee. Okay. We don't really care who gets picked first. We're making this committee, right? We're making this committee, and order doesn't matter. Downloading apps on your phone, like in general, if you just have the apps on your phone, right, they're there. Unless someone says how many ways can you arrange it on your home screen, now we're talking order matters. But in general, if you just want like that package of apps, if you have the app, you have the app. Like we wouldn't consider them being in a different spot on your screen as a different arrangement, because we don't care about the order in that case. A hand of cards, okay? If it's asking for a hand of cards, there's a deck of cards at the back of the booklet that I'm going to show you a bit later, not right now. Then it doesn't matter, because if your hand, if it says how many hands of cards can you have, let me see if I have a deck of cards. I gamble on the side. Sorry, make my extra moolah, right? But let's just say, okay, here's my deck of cards. Okay, so in this case, if it's just talking about the hand, it wouldn't matter where you have them, right? As long as you have that hand, this is considered a particular hand. You having the 9 here or here, we wouldn't count it twice. You have, this is one hand, and the order doesn't matter in this particular case. If you're arranging this, oh, somebody wants to make a picture, take a picture, how many ways can you have these arranged for the picture? Like the question would kind of make note that order matters. But normally cards, it will just say a hand. How many hands can you possibly make out of that, okay? So here's the formula for combination. Some of you need to have a review here. Permutation, write this down, it's NPR. And it would be n factorial, so whatever this number is, factorial, and in the denominator is n minus r factorial. We did that on the AC today, right? The formula for combination is, it's very similar, but what's the noticeable difference? There's the r factorial, right? So we divide by r factorial. So this is basically getting rid of the order matters part. This right here, you're taking r and adding it to it. So 2 different ways to state it. NCR, make sure you have this on your formula sheet, your study sheet, as well as permutation, because sometimes you might need it. Another way, alternate notation. Another way of saying the exact same thing is just 2 big brackets like that, and they'll just go NR. You know it's combination when you see this, okay? And it's exactly the same formula on the right-hand side. Again, you're not going to use it very often, but it is there nonetheless. So let's look at some specific examples here. Anna, Bernadette, and Clara. If you wanted to do a permutation where order matters, arranging for picture. That would be a very classic, or positions. Like president, vice president, treasurer, right, etc., then order matters, right? You getting picked for president or vice president it's different, right? So then it would be how many ways can you do that? 3, 2, 1 ways, right? If there's 3 people and you want to arrange them for something, be 3 times 2 times 1, which is 3 factorial, which is 3 pick 3. It's all still 6 ways. 6 ways. So we can actually show that A, B, C, right? If they're standing like this, that'd be 1 permutation. If you go A, C, B, you flip the last 2, that would be another one. Let's say we have Bernadette front. We would have Bernadette at the front, and it's A and C. We could have another instance where Bernadette is at the front, then we have C and A. We can have another one where Clara is at the front, and we've got Anna and Bernadette next to each other. Another case would be Clara's up front, Bernadette is in the middle, and Anna at the end. So there are 6 unique arrangements. So it could be pictures, lining up for pictures, or where there are specific positions, you name it, there are 6 different ones. For combinations, okay, you need 3 people to be part of a committee. Committee would be a good one. How many ways can you arrange the letters in the word committee, right? But then order doesn't matter. I will put it up here next to combination here. Order does not matter. So you would go, essentially, let's try this. It's 3, choose 3. We use the word choose when we use pick when it's permutation, choose when it's combination. Let's go find, how would we enter this? 3, sorry, clear my screen. 3, and you got to go alpha, window, and we used NPR before, now it's NCR. Okay, so it's option number 8. And then go by 3 again. 3, C3 is just 1. Let's use the formula real quick. 3C3 would be, this is n, right? It calls for n factorial over, what does it call for next? Where's the formula? The one in orange, that's r factorial, right? What is r for us here? It's this number, which happens to be 3 as well. And then it's brackets n minus r, 3 minus 3 factorial. I'm going to keep the top as factorial. That's 3 factorial times 0 factorial. Anybody remember what 0 factorial is? 1. Okay. So it's just 3 factorial over 3 factorial, which is 1. Okay, so there it is, confirmed using, having done it by hand. So if it's a word problem and they don't ask you about doing this by hand or showing work, you just go 3C3, get me the number. Okay. In fact, I will say this, a little rule here on the side. Note, I think these ones are very good to have on your study sheet. If you ever have 5, choose 5 is always going to be 1, right? 10, choose 10 is always going to be 1. So when both numbers are the same, you're always going to get a 1. Because guess what? If you have 10 people in the room and you need to make a team of 10, and order doesn't matter, it's always going to be 1, right? Out of the 10, I'm going to choose all 10. Boom, I've got my one group. That's it, right? So it's always going to be the same. And another one is this. Put it right next to it. 5 choose 1 is always going to be 5. Or 10 choose 1 is going to be 10. You see the pattern? If you're only choosing one person at a time to make that, it's not even a group, right? It's not even a committee, like, right? But anyways, but if you go 10 choose 1, it's going to be 10. And this one, the last one here, 5 choose 0, it's also going to be 1. This one I'm not going to take the time to explain. For now, you just have to trust me. If you use the formula, you would get 1. Okay, so this is your little, it's a good cheat to have, a little thing to have on your study sheet, because you can save yourselves a lot of time not having to type in all of these scenarios. So basically, if both of them are the same, it's 1. If you have a number followed by 1, it's going to be that first number is going to be your answer. If you have a 0, regardless, it's always 1 as well. So just be warned. Let's go back to our scenario here. We have 3 people. We need to make a group of 3, a committee of some sort. So there's only one way to do that. And basically it's saying note, ABC is exactly the same as ACB, which is exactly the same as BAC, and they're all the same, all the way down to CBA. That's the last one we have on the left-hand side here. Like, we consider them all the same. You can make one group or committee. And now, this is the time that I tell you, this is why I stopped calling, when 2 people are grouped together in that arrangement, I don't want to use grouping there. I'm just going to call them together. This is like making a group, like making a team, making a committee, a debate. Like if you're debating and you have like 20 people that are in that club and you just need to choose 5 to represent Sisler at this debate competition, you're just making a committee, a group. It's combinations. It's not, order doesn't matter. Okay, let's go to 52 here and see how we can apply this. Yep.
You need to spell it.
Yeah. Alternate notation, yes. My bad. Notation. Yeah. Got it? Thanks for that. Thanks for reminding me that I'm human. All right. There are 12 hockey players. How many ways can a coach pick a right wing, a left wing, a center, a right defender, a left defender for her starting lineup? Do you think order matters here? If let's say I'm part of that guy, pick me, coach, pick me, right? If I get picked first, I would be a left wing. If I get picked second, right wing, I would be a left wing if I get picked second. If I get picked third, I'd be a center. So there are specific positions. Okay? So it does matter. It does matter in this case. Order does matter. So I wanted to start with, let's go back to what we've been doing all along. Okay? So I will just say here, specific positions always result in a permutation. Permutation. What's going on today? Okay, maybe the turkey is messing with me. That's what it is. So specific positions always result in a permutation, okay, folks? VP, president, treasurer, defender, like whether having specific positions will tell you that it's permutation. So we can say we have, you can do it this way: right wing, left wing, center, right defender, left defender. Okay, so if you want to do it that way, that's fine. We used to not really pick on that too much. We just say there's 12, right? So you have 12, 11 left for the next position. Would it make sense that this drops on a team, right? You can't have, like, let's say I'm back on the line, like I want to be picked, right? I can't be right wing and left wing, right? I can't do, so it's assuming that we can't do both at the same time in this case. The context tells us that. Or we could have just gone 12, pick how many? How many are we picking? 5, right? Both of these are saying the exact same thing. I don't want you to forget about the permutation notation. So you can either go 12, pick 5. So grab your calculator and you just go 12, alpha window, you pick 5. So that's 95,040 lineups. Obviously, we would not be considering skill, right? There are certain players that are like, I'm a left wing, right? That's just it. But we're not considering that. We're just saying how many different ways, how many different teams can you essentially have if it matters which position you play. If the question were to say, right, the coach needs to pick 5 players for her starting lineup, no particular positions. Okay, that's bullet number 1. No particular positions, only focuses on making a group of 5. And when you say making, put underneath selecting. It's the same thing. Making or selecting a group of 5. That's all it cares about. Therefore, combinations. Okay? So, I go back. Okay, forget about A right now. Forget it. Erase it from your memory, okay? All I'm saying is, okay, I've got 26 of you in this room right now. I just need to make a group of 5 that's going to represent, that's going to do a presentation on applied math in the next assembly. I don't care who's who, right? Who goes first or whatever. I just choose 5. Like, how many ways can I choose 5 from this room? No particular positions. It would just be 12, choose 5. Okay, I'm not going to do the fill in the blanks in this one. I'm just going to say it's 12, choose 5. That's it. So let's do the math here. It's going to be a lot less. It's going to be a lot less than 95,000. Okay? So 12, choose this option number 8. 12, choose 5. 792. 792. Groups or teams, technically, like teams or lineups. Okay, so that's how it's different. Okay, no positions here. Over here, we had specific positions that need to be filled. So me, like someone being picked first or second, matters here, but not over here. Just any 5 will do. So that's just it. Okay. Can you simplify using the formula? I just need a short break. Simplify the following by hand. Using the formulas, they're on page 51. You have both. You have NPR, you have NCR. I want you to simplify it using the formulas, okay? Simplifying mean, don't just give me the final answer right away, break it down, cancel things out, so that there are no factorials left, and then give me the final answer. Okay, the first one. That's how you start. So combination's a little trickier. Okay, so this is how you start. You break it, you fill in, you break it down like that. I will start with the top here, 8, 7, 6, 5. I'll stop at 5 factorial. Why? Because there's a 5 factorial in the denominator. What about the 3 factorial? Just go 3 times 2 times 1. Like that one, you break that one down. So you cancel the 5 factorials like that. And at this point, just give me what the top is, give me what the denominator is 6. The numerator is, I forgot already. 56 is the final answer, right? 56 times 6. 336 at the top. And then divide by 6, so that's 56. Okay, so just show as much work breaking this down. It's good practice. I would want you to be able to do that. NPR, this is the permutation. That's easier. 10 factorial over 10 minus 3 factorial. So that's really 10 factorial over 7 factorial. You just have to cancel out the denominator really. Like that. Cancel out the 7 factorials. And that would be 72 times 10, 720. So there we go. So that's how you do that, okay? You'll get to practice a little bit later. Create a word problem for A. So A, you're thinking it's choosing, right? So from 8 people, select a team of 5. That could be one scenario. From 8 people that you have, we need to select teams of 5. How many teams can we make? For B, we notice it's permutation. Order matters. Okay? So you make devise a question. You can say, how many ways hold on. I think the question, I'll leave it for the end. I'll undo this. Undo. There are 8 people and 5 are selected for a picture. Picture is the key here. How many arrangements can be made? That has come up before. I will just say for A, order doesn't matter, right? Combinations, order is irrelevant. Okay, just making a team of 5. But the emphasis, you have to take care of the 8. I know. How many people do we have on B available? 10, right? Can you change that to a 10? And how many are we arranging at a time? 3. I thought I had a good day. A good day today would be to go home. That'd be a good day. 10, 3, okay? So from 10, I have to go by that scenario. So pick order matters. So what else could you have said? You could have been like, there are 10 people running for president, vice president, and treasurer, right? Or secretary. How many ways, how many different arrangements could have been made there? So just come up with specific positions that also, that's a check mark that you put next to it. Okay, let's put this to practice here. How many ways can you pick 3 different flavored ice cream scoops from 10 available flavors? Does order matter here? I think this is somewhat unfair because maybe you're like, no, strawberry has to be on top, vanilla and chocolate bottom, right? But in general, here it wouldn't matter. Just have the 3 flavors in there, right? Unless, have you ever ordered 3 scoops of ice cream and told them which order to put them in? You have? Okay. Anyways, I just say I want these 3 flavors and then they do whatever they do, right? So this would be combinations. Order does not matter. Okay, so this would be from 10 flavors, you choose 3. 10C3. So it'll be 120 options. So you don't see me doing the fill in the blanks with combinations. I don't know if you've noticed that, right? For the most part, I don't. So this is more like it. The next question is more like it. They're given that there are 5 juniors and 4 seniors, right? How many ways can teams of 4 be selected if there are no restrictions? So teams, you should think combinations. Selecting teams of 4, there are no specific positions, so you don't really care. How many are available? How many do we have to choose from? 5 and 4 is 9 total, right? So from 9, we're going to choose how many? 4. That's it. There's 126 teams that can be created with the people that are available. But now it gets trickier. What if you want exactly 2 juniors to be on the team? Now I need to split it up. So you want basically 2 juniors and 3 seniors, okay? No, sorry. Teams of 4, Mr. Dirksen. 2 juniors, and therefore I need 2 seniors, correct, to make my team of 4? So how many juniors do you have? 5. So to fulfill this first requirement, from the 5, you're going to choose 2, and from the 4 seniors, you're going to choose 2 as well. So from the 5 juniors, you choose 2. From the 4, you choose 2. So one thing I want you to notice is that these 2 numbers give you the 9 total. You're still having 9 people available in total. And then these 2 numbers here is the team of 4. So you kind of want to look for, do the first 2 numbers add up to the total that I have, which is 9, and do the 2 numbers that follow each combination give me that team of 4. Okay, so let's figure this out. What does 5 choose 2? I'll do it for you. It's 10. And 4 choose 2 is 6. So there'll be 60 teams that would fulfill this requirement. Can you do the next one? Based on this pattern, see if you notice the pattern. What if I asked you, I want exactly 3 seniors on the team? Go ahead, do it, do it. Okay, time is tight, so if the question says 3 seniors, you still have to make sure that in total you've got 4 people for your team, right? So from the 4 seniors, you're going to choose 3. And from the 5 juniors that are present, you're going to choose 1. Okay? So these numbers add up to your team of 4. These 2 numbers add up to your team of 9. So that's one thing you want to check for. What's 4 choose 3? 4 choose 3 is 4. And do you remember 5 choose 1? What do you think this is going to be? 5. So there's 20 teams that would satisfy this condition. Okay. And now your favorite. What if the question says at least 1 junior has to be on the team? I'm going to focus on indirect reasoning. We're going to go this way. Total minus, if you want at least 1 junior on the team, what are we going to subtract here? I'm going to subtract all the teams that have no juniors on them. I'm going to take my total, which is what, by the way? Do you remember no restrictions at the very top? 126 ways, if I didn't care about who's who, junior or senior, if I didn't care, this would be my total. So we'll have to figure out the no juniors here. Can I do this one here on the side here? So 0 juniors, so how many seniors do I have to have if there's 0 juniors? 4 seniors, right? Okay, so from the 5 juniors, I'm going to choose how many? 0. And from the 4 seniors, I'm going to choose all, right? I need to choose 4. What's 5 choose 0? 1. What's 4 choose 4? 1, right? You can only make 1 team out of the 4 if order doesn't matter. So that's just 1. So what's my total? My total was 9 choose 4 minus 1. 9 choose 4 is 126 minus 1. That would be 125 teams. 125 teams would have at least 1 or more juniors in them. Emphasis on the at least. If it said exactly 1 junior in him, you would go back to what we did before. If it's exactly, you just have to worry about the 1 case, right? Here, if it's at least, there's a bit more work involved. Okay, if I run out of time, I want to do the cards real quick here. I'm going to ask you to try pages, it starts on page 62. Let's go to 64, but there will be some that you won't be able to do. One question in particular I see you won't be able to do. So if you come across something weird that you haven't seen before, just leave it. Okay? Let's do the deck of cards, next page here, 54. For now, I'm not going to go over the deck of cards. I'm going to give you a little cheat sheet thing for tomorrow. There's a deck of cards at the back. There's 13 of each suit. So how many cards in total? Anybody? 52 cards. You can split them in half. How many black cards are there? 26 are black. This is at the very back of the booklet. 26 are red. How many aces? 4. How many faces? See what I did there? Aces. Faces. How many faces? 12, right? 12, because each suit has 3. So these are some of the terms I would expect you to know. Right? How many red faces are there? If there's 12 faces, then 6 of them are red. Okay. How many club faces? If it's just clubs, then it's just the 3 here, right? So don't worry about it too much right now. If you're a little bit like, what? I don't play cards, Mr. Erickson. What are you doing this for? It's a bit of a classic, okay? A deck of cards is classic, and I'll give you a cheat entry for your study sheet tomorrow, okay? But how many ways can a hand of 5 be dealt if there are no restrictions? No restrictions. Combinations, correct? This is back to 54. I'm rushing a little bit, I know. We've got 52 cards, and we're just gonna choose 5. That's 2,598,960 hands. Order does not matter. Whether you have the ace first on the left of your hand or ace at the back, it doesn't matter. We don't care about that. So that's how many hands. You can have no black cards. What if that is a restriction? So, wait a minute, how are we going to do that? Okay, out of the 26, so we're going to have 0 black cards. So how many cards do we need yet? We still need a hand of 5, right? We're going to have 5 red cards. If it says 0 black, then we have to have 5 cards. So that means that we need to pick our 5 remaining cards from the red pile, correct? So we would go, how many black cards are there? 26. Choose how many? 0. And from the 26 red cards, I'm going to choose all 5. What's 26 choose 0? It's just 1. 26 choose 5. What do you mean? You don't know that one? Anyways. 65,780 hands. Again, does the 26 and the 26 add up to 52? Yes. Does the 0 and the 5 add up to the group of 5 that I need? Yes. So that's what you want to check. Okay. At least 1 heart. This one is also part of your homework. You would go total minus, what would I put in here? At least 1 heart. That way I'm going to go total minus the cases that have no hearts. Figure out all the hands that would have 0 hearts in them. So if you want a side note here, 0 hearts. How many non-hearts are there? 52 minus 13. Anyways, pages 62 to 64, okay? Very important.